Hello and greetings to everyone. We are going to continue from where we ended. We are going to treat the nature of roots of a quadratic equation. Take this down, nature of roots of a quadratic equation. That means we'll be able to know whether the quadratic equation has two real distinct roots, or the quadratic equation has repeated roots, or the quadratic equation has complex roots. When it has complex roots, that means the roots are not real numbers. Let's take this down. If the quadratic equation ax squared plus bx plus c equal to 0, has solutions, x equal to alpha or x equal to beta, then alpha and beta are said to be the roots of the quadratic equation. Now the next thing what we need to know is whether alpha and beta, they are real distinct numbers. That means they are real numbers which are different, or alpha is equal to beta, they are real numbers which are equal, or alpha, beta are not real numbers. That means they are complex numbers. We take this down from the quadratic formula. This is the quadratic formula. X equals negative b plus minus the square root of b squared minus 4ac divided by 2a, the value of the expression, I'll write it down with a red pen. You can see b squared minus 4ac is under the square root sign, will determine the nature of the roots of the quadratic equation. Nature of roots of the quadratic equation in question. It is called b squared minus 4ac. It is called the discriminant. As the word sounds, discriminant. We think of discriminate, and we denote it by using a triangle as such, a small triangle. It's called the discriminant of the quadratic equation. That's how we call it. That is the discriminant is equal to b squared minus 4ac. So you take note of that. Now we take 1 by the margin I if the discriminant b squared minus 4ac is equal to 0. If we take the square root of 0, it remains 0. Then x will simply be equal to, from the quadratic formula, x will simply be equal to negative b divided by 2e. In this case, we say the quadratic equation has equal roots. Let's put the conclusion. The quadratic equation is said to have equal roots. That is, x is equal to negative b on 2e, or x is equal to negative b on 2e. In such a case, we say the quadratic equation has equal roots. We take now 2i. If the discriminant b squared minus 4ac is greater than 0, that means it is positive, then we are going to have x to be equal to negative b plus or minus the square root of a positive number, b squared minus 4ac divided by 2a. And at this level, we are going to obtain x to be equal to negative b plus the square root of b squared minus 4ac over 2a, or x is equal to negative b minus the square root of b squared minus 4ac all over 2a. Here, the conclusion will simply be the quadratic equation has two real distinct roots. You can see they are different. The quadratic equation has two real distinct roots. We go now to 3i. If the discriminant b squared minus 4ac is less than 0, that means it is negative. Look at the quadratic formula, that means we'll be taking the square root of a negative number, which is not real. Then the square root of b squared minus 4ac will not be possible if you're using a calculator. But under complex numbers, we are going to see that this will be possible. Since we are taking the square root of a negative number, we are going to see how to find the square root of negative numbers when we treat complex numbers. In this case, we say the quadratic equation has no real roots, or we can say the quadratic equation has complex roots. We are going to see this when we take complex numbers, so you take note of complex roots. Now let's take exercises for application on this. We see how to determine the nature of roots of any quadratic equation. It goes, find the discriminant and determine the nature of roots of the following quadratic equations. For A, we have the quadratic equation 3x squared minus 5x plus 2 is equal to 0. For B, we have the quadratic equation 4x squared minus 25x plus 49 is equal to 0. For C, we have the quadratic equation x squared minus 7x plus 3 is equal to 0. For D, we have the quadratic equation 5x squared minus 7x plus 3 is equal to 0. We take solution. For A, it says we should find the determinant and determine the nature of roots. First thing, we are going to start by comparing the given quadratic equation 3x squared minus 5x plus 2 equal to 0 with the general form of the quadratic equation, which is ax squared plus bx plus c equal to 0. If we compare, a will be equal to x squared, so a will be equal to 3, b will be equal to negative 5, and c will be equal to 2. We know the discriminant is given by b squared minus 4ac. We are going to replace the values, so this will be equal to negative 5 squared minus 4 times a, 4 times 3 times 2. This will simply be equal to, we know negative 5 squared gives 25, negative 4 times 3 gives us negative 12, negative 12 times 2 gives negative 24, 25 minus 24 gives us 1. 1 is greater than 0. That means the discriminant is greater than 0. We know when the discriminant is greater than 0, that means the quadratic equation has two real distinct roots. We conclude, therefore, the quadratic equation quadratic equation 3x squared minus 5x plus 2 equal to 0 has two real distinct roots. We go now to B. For B, we have the quadratic equation 4x squared minus 25x plus 49 is equal to 0. If we compare this quadratic equation with the general form of the quadratic equation, we are going to obtain our A to be equal to 4, B negative 25, and lastly C 49. We know the discriminant is given by b squared minus 4ac. This will be equal to negative 25 squared minus 4 times a is 4 times 49. This will simply be equal to, we know 25 squared is equal to 25 times 25, which is equal to 625, minus, we know 4 times 4 gives us 16. 16 times 49 gives us 784. And this will simply be equal to, if we take 625 minus 784 gives us negative 159, which is less than 0. Since the discriminant is less than 0, we conclude therefore the quadratic equation for x squared minus 25x plus 49 equals to 0 has complex roots. We go now to C. For C, we have the quadratic equation x squared minus 7x plus 3 is equal to 0. If we compare it with the general form of the quadratic equation, our A will be 1, our B will be equal to negative 7, and our C will be equal to 3. We know our discriminant is given by b squared minus 4 AC, and this will simply be equal to negative 7 squared minus 4 times 1 times 3. This will simply be equal to 89 minus 4 times 1 gives 4 times 3, 12. We have to subtract. If we take 49 minus 12, it gives us 37, which is greater than 0. Then we conclude the quadratic equation x squared minus 7x plus 3 equal to 0 has two real distinct roots. We take question D, the last one. We have 5x squared minus 7x plus 3 is equal to 0. Here, compare this with the general form of the quadratic equation. Our A is 5, B is negative 7, and C is equal to 3. We know our discriminant is given by b squared minus 4 AC. So this will be equal to negative 7 squared minus 4 times A is 5, C is 3. So this will simply be equal to, negative 7 squared gives us 49. Negative 4 times 5 gives us negative 20. Negative 20 times 3 gives us negative 60. If you subtract, this will give us negative 11, which is less than 0. We conclude the quadratic equation quadratic equation 5x squared minus 7x plus 3 equal to 0 has no real roots. In bracket, the right has complex roots. And we are done with the correction of the exercise for application. So this is all what you have to know about the nature of roots of a quadratic equation. You must memorize the formula for the discriminant, which is equal to b squared minus 4 AC. Please, if you like the video, share and subscribe to this YouTube channel. Thank you very much for watching.